So even though these speakers are vinyl wrapped, albeit quite a hard vinyl, they do need keying up still. So I have sanded these and paid particular attention to the corners just to feather them out. So there's no sharp or rough edges to these anymore now. Along here, this was all frayed and blistered and that, so that's all now really smooth. So whilst we've feathered out the vinyl there is no high spots or anything. That I may fill. There is a edge there that just won't come out. And again, we've softened all the corners out. Along here, the back. So really good. So where we've had that corner knock, I do need to fill that. But otherwise, yeah, they're pretty much ready for wrapping. There we go. Once that's dry, we'll flatten that off. Bit there as well, just to feather that out. There we go. Right, so all of these bits that needed filling have been sanded back now, filled and sanded, and that's lovely. There's nothing there now. So yeah, that's going to be a good base for our new wrap. This corner knock has come out well. I need to put a teeny bit more filler at the top there, but otherwise we've got the shape back in that. So yeah, sometimes you have to do kind of 2 passes with your filler. But yeah, these are all softened out and nice. Nothing spiky, so yeah, they should wrap up quite nicely. Yeah, very good. Probably a bit earlier than I needed to do them, but I've vinyl wrapped these now. I won't remove the protective film. You can see how glossy it is underneath that. Can you see that little bit actually on there? So yeah, I won't remove the protective film until I've done all the crossover work and drivers and everything else. A bit early to wrap them really, but hey, never mind. And then I'll go over them finally with a heat gun and just make sure everything's nice and tight. But yeah, they've come out well. They're going to look good. So obviously vinyl wrapping is not as good as a professional sprayed finish that's then kind of flattened back and polished. But yeah, once the protective cover comes off, it's actually really good. So yeah, coming along. Right, so I'm using my trusty crossover board and beginning to construct a new crossover for these PSB speakers, but yeah, just shooting raw measurements and stuff from the drivers, I am struggling to get them to meet. So I'll just show you some crude measurements. Right, you'll have to excuse the fact that I am videoing my screen and as yet I haven't sorted out a way of capturing it properly. Right, I've not long started with this, and yeah, it's fairly interesting really. So if we just look at let's just look at the raw drivers. So these are all taken 1 meter on tweeter axis. So this is the raw drivers without any crossover. So the tweeter, so I've highlighted that, hope you can see that, at around 3.5k has that little bump and then it starts rolling off, and it's not particularly sensitive. With 1 watt you would expect that output to be a bit higher up, and that's a problem because if I want to flatten out that peak at 3.5K and just get it to play lower, I can't really do that because I'm limited on how I can cut it back with an inductor, for example. And yeah, it doesn't really work particularly well, I don't think, with this woofer. So here is the woofer. Woofer's pretty good, but the peak you can see at about 1300 hertz is coming from the box. The fact that there's absolutely no like polyfill or anything in there. Whilst the box is well braced, you've just got this little skin of looks like sort of carpet underlay stapled to the panels. And this is one thing I've mentioned before. If you heavily brace a box, you push the box's resonance up high, which I think is probably what's happening here. So, you know, you could see that if you took an imaginary line across here, then things are looking quite good, and it's rolling off naturally 3-4K, and then we get all screwy down here. So really I wouldn't want to be using this much higher than 2. Start rolling it off there. This we can probably kill with some polyfill and some better foam inside the box. And if I look at the where are we? Let's just bring this down a bit. You can see that 1300 hertz peak is ringing resonance inside the box. So that's kind of the issue we've got. So what I will probably do is stop doing this now and address the filling inside the box. Hopefully that will take that peak out. There's another rise here, might be a reflection of that inside the box. Not too sure yet. So yeah, I'm playing around with second order slopes on the tweeter and the woofer. The woofer behaves a little bit better if let's just turn some of these off. So that's just with a second order slope, a 1.5 millihenry inductor. I'm sort of rolling off, starting about 3, which is too high. I want to pull this back further, but looking at the tweeter with a second order filter on it, where's that one? It's playing quite nicely, but I'm struggling to pull it this way because it's already rolling off. So what I can do is pull this part down with an inductor, but then its output's going to be really low compared to the woofer. And you don't stick resistors on the woofer, you attenuate the tweeter. So yeah, it would be nice to see this coming over here and then pulling down. I might be able to shunt a bit more power here, playing with the shunt inductor, but we'll see. Anyway, that's where I am, and I will probably pick this up when I get to a point where I'm about there. Okay, I've added a bit of polyfill inside the box and some foam in the middle. I'll probably revisit this, but as you can see now, this has come out quite a lot. So currently that's where I am on axis. That line there that's flashing. Ignore this. This is the room. I haven't gated these measurements. It doesn't make a huge amount of difference in here actually. I'm already cutting my measurements off at 300 hertz, so yeah, kind of ignore that. And that's pretty good. One thing I can't seem to address on axis, that is this little dip we have here. It was there in the original crossover design and it's still there now. So you can see the tweeter's response is actually up here. Excuse me, hay fever again. But when we run it with a woofer, we get a bit of cancellation here. Flipping the phase of the tweeter doesn't make any difference. In fact, it just dips this out. So I've got a second order filter on the tweeter. I'm, rather than a 4.7, which was what was on there originally, I'm using a 6, so 6 microfarad, and that's allowing this to play a little bit lower. The problem is it's rolling off here anyway. I could really do with a tweeter that would play, say, up to about 2.5k before it started rolling off. I mean, the dome on that tweeter, I think I said in the original video, it was like 3/4 of an inch. It's not, it's 1/2 inch. And it's quite good in this range, but then we peak and then drop off. So it's not great. The important part is the woofer. So I've now got a second order filter on that, whereas before it was a first order and it just, you know, started to break up all over here. Now we are rolling off quite nicely, and if I just run a test tone for the woofer alone, you'll hear how that is now really dropping off. So there's hardly any top end to that at all now, which is really good. So crossover point is now about 2.5k, which is much better. I would like to get it lower, but I'm fighting that tweeter, and 2.5k is much better than 4. When you get a woofer that size to play up that high, it's just, it can't accurately reproduce those high frequencies, and it will just be muddy and horrible. So the clarity improvement here is going to be, yeah, quite important, I think. So if I look at the, I'll clean this up at some point, but it's just a bit easier to see. Phoenix likes quite a laid back speaker, and that to me normally means rolling down the 1 to 4k area, which is kind of naturally happening anyway with that woofer. So I'm expecting this to be quite a bit better in terms of bass output. 50 hertz, 40, 30. There's a lot of things vibrating in this room. It's, yeah, it's good. So you know, this showing up in my measurements is artificial. It's the room. So I sort of ignore it really. From 500 hertz down, I'm not going to do anything to sort this out because it's not there. If I near field test that, or probably gate it, this will come back up. But yeah, I'm fairly happy with that. I'm going to do some off-axis measurements now. But yeah, I'm quite happy with that. I'd quite happily say that from 300 hertz up to, I don't know, 18k, we are plus minus 2 dB. So yeah, for crude clip together on the crossover board measurements, that's not too bad at the moment. So I think I'm going to go with that. So I've used a 1.5 millihenry inductor on that woofer because it does need to play up higher than we'd really like it to, with a 3.3 microfarad capacitor. If I use a higher value capacitor, I will steepen off this roll off. But what happens then is I'm almost tucking the shunt part of the second order circuit underneath the inductor, if that makes any sense. So the amplifier sees that as a bit of a short, and that starts pulling out more power. In fact, if I change that for a 10, I'll show you what I mean. So let's change the color of this so we can actually see it. Let's go for blue. No. I don't know. So hopefully what you can see there is we've now pulled the roll off back, but we are shunting some more power. So we're lifting this bit up here because we're kind of, our capacitor value, the higher up in value you go, the further back you'll pull your crossover roll off point, but at the same time you'll be peaking this up because you're kind of going past the inductor value, if that makes any sense. So yeah, that's one way of filling in a lump, but you know, it's causing us other issues here. If I swap our tweet around, we're not going to improve that, I don't think. Yeah, we do a bit, but we're still going to have that horrible lump there now. So if I highlight that measurement, there you go. Yeah, that's not going to be nice to listen to. You're going to have a lot of output at 1200 hertz, and then it's going to drop down 5 dB. So that's not what we want. We want a smooth transition between the frequencies, not big cliffs. So yeah, anyway, I'll do a full video at some point, bore the hell out of you all on crossovers and just how values change things. But yeah, that's where I am. I'm going to do some off-axis measurements now, and then I think I'm probably quite happy with these. Then it's just time to listen to them and yeah, go from there. Anyway, catch you soon. So the last thing I do once I finish with the crossover board is twist and clip all those components together behind the speaker. Whilst I've still got quite a few jumper wires there, it's not as bad as it is with my crossover board. There's a lot of resistance that's introduced with the cables going from that to this, so I just clip it together and measure it again. 9 times out of 10 it ends up being pretty much identical, but my tweeter level plays a little bit higher without that resistance of the cables in it now, so I've had to quickly alter that resistor value. But yeah, I know where I'm going with it now, so all good. Okay, that's our new crossovers together. All of that wasn't going to fit on that, and even if it did, you wouldn't get that back through the hole. So I have some more binding post cups, exactly the same as those, with some decent brass binding posts on, so I'll be using these. Phoenix can have these back as they are, and just retain them. So yeah, whilst we've changed the crossover design, there is a marked improvement in components. I hope you can see that and yeah, understand that. Okay, so I'll go through what we've ended up with, and it's measurement wise worked out really well. This is going to be a huge clarity improvement, so yeah, pretty good really. So this is our positive and negative in. So if we look at the woofer circuit, we come in from the positive into our inductor, out to our woofer, and also picking up these capacitors here down to ground. And then on our tweeter circuit, we come in through these capacitors first. We pick up this inductor down to ground, and then we carry on through a 2.2 ohm resistor out to our tweeter. So previously here we had a 4.7 microfarad capacitor, this horrible electrolytic thing. We've now got a 6 microfarad, and this inductor has gone from 0.3 to 0.35, so not a huge change. And then I think before we had a 1 ohm resistor in series with our tweeter after the caps. This is now a 2.2, so that's just allowing our tweeter to play a little bit lower. With the woofer, we've got a 1.5 millihenry inductor, and these total 3.3 microfarad, so second order. Works really well. All point-to-point soldered. These will be soldered to the drivers, this to the new binding post. Job done, I would have thought. I think it's worth just having a little natter about the reason why you don't see components like this in a lot of kind of not budget or lower end, but sort of cheaper speakers, and you end up with this. It's cost, absolute cost. You know, if you look at this crossover here, we've got this horrible little electrolytic capacitor, which is probably like £1, if that, 50p. Decent air core inductor actually. Interesting to see that in when everything else is a bit junky. I don't know, say that's £3 or £4. Little resistor there, £1. This laminated iron core inductor, I don't know, there's probably £10–12 worth of components on that, if that. That inductor alone is about 14 quid. So, you know, if you add this up, so say we've got, round it up, £15, £5, there's 20. These resistors are a couple of quid, £22. And then capacitors are 2 or 3 quid each. So there's probably £30 worth of components on this. So that's £60 for the pair. Whereas you can do 2 of these for 20 quid, something like that. So that's the difference.